In this video, we're going to talk about the final application for finance, which is amortization and an annuity. So far in this course, when we've been talking about finance, we've mostly been talking about compound interest or simple interest. And in both of these cases, it's when you take a one-time payment and you see what happens over time with interest. But that's not really realistic in our context of the world. Most of the time, people don't only invest one time in their life and look at what is at the end of their life. They might be investing every month, every year, every day, but there's many different investments that are done, and each of those investments is gaining its own interest. And we're going to be looking at this type of concept today when we're looking at an annuity and amortization. Before we start, I'm going to give you some formal definitions of what both of these things are. And we're going to make sense of this afterwards. First, an annuity. This is when an investor makes regular payments into an investment, all of which accumulate interest at an equal rate. So, this could be an example of saving up for retirement, where you're investing a portion of your paycheck every month. And every time you invest, each of those investments is increasing with interest. So you see, i.e., you are investing a certain amount of money and the bank pays it back to you with interest by means of regular payments. Another situation is amortization. Now, amortization is the process of repaying a loan on which interest is charged with regular payments. So we often hear this term about killing off a loan. Here, we're going to be having a certain amount of money that's given to us by the bank. And then the process that we're going to be repaying the bank, well, the bank is going to be charging us interest on the money we still owe while we're making regular payments until we're able to pay everything, including the interest. So we're going to talk about how we can calculate this type of situation. In this part of your notes, I want you to try and either graphically or with words explain what is your definition of an annuity and amortization. So in these boxes, I want you to try and explain it, what you understand from an annuity and amortization. And I'm going to start by talking about an annuity. What I did is I drew a timeline. So this is a timeline. It could represent month or years. I'm going to decide for it to represent years. What's happening when we have an annuity is that you're saving up for something. So you could be saving for retirement, right? Or you could be saving to buy a car. You're saving for something. And in order to save for something, well, not everybody has like $100,000 that they can just put into an account and see how the interest grows, right? We mostly have 100, maybe 1,000 that we can give. So what happens when you're saving for a big thing like a house or a car is that you're going to be able to put, let's say, 100, we're dealing with years, $1,000 in year one. Well, this $1,000 you put at the bank, and this $1,000 is going to gain interest year after year after year. So usually this $1,000 we could use like a compound interest formula, and we could have, let's say, a rate of 5% each year compounded annually, and then we could do this, let's say, for 10 years. Right? So this amount of money will be increasing in your bank account for 10 years. Well, what happens in year two is that in year two, you're going to invest another $1,000. And this $1,000 is going to gain interest year after year after year. Well, this $1,000 is going to have the same interest rate, of course, because it's the same bank account. But instead of gaining interest for 10 years, it would only be gaining interest for 9 years, right? Because you put it into the account at year two. And then you would continue this process. In year three, you would have another amount of money. We're always going to have the equal payments being exactly the same. And this 1,000 would be getting the same interest, but this 1,000 would be gaining for only 8 years. And you can kind of understand that this continues for the 10 years. And the money that you have into this annuity fund is the sum of all of this, right? And your calculator is going to be calculating this situation. It's going to be calculating the interest for every single investment and giving us a total. So this is the process that's happening in the calculator when we're dealing with an annuity. You can imagine that we don't want to do this by hand because that would be a lot of different calculations for us to even take into consideration. Now, for amortization, slightly different. With annuities, we're saving for a car. So we're starting with zero money most of the time, and then we'll end up with some money in the bank account. Amortization is something that we use mostly for repaying loans. So we can have repaying loans is one of our typical example for amortization. Or when you've retired, you get payments from your retirement fund. So getting payments from a retirement fund. These are two main examples that we see often with amortization. And with this situation, you're starting with money in the account. So let me draw a little timeline for us. Let's draw my timeline at the bottom. Let's change it up. And this is time, let's say also in years or months. And what is happening is that you are starting your time with already money in the bank account. So all of this is money in the bank account. Maybe the bank lent you $100,000, or you've saved up for your retirement and you have $100,000. I don't know exactly what this number is, but you start with money in your account. And every month or every year, let's talk about paying the loans. Every month, you are giving the bank a certain amount of money, right? So you're taking this much off the loan that is owed. Well, what the bank does is it removes this amount, perfect, but you still have all of this left to pay. And now the bank charges you interest on this green part. So they're charging you a slightly more than what you had left over to pay, right? So there's a certain amount of interest. Let me highlight it in green. There's a certain amount of interest at the top here. Well, what you're going to do in the second year is going to pay another chunk of what's here. So you're going to pay an equal amount than you did the year before. And then the bank is going to go ahead and charge you interest on what is left over to pay. So always a little bit more. So we have this situation that every year you're getting charged interest on what's left over, and you're paying a certain amount constant each year or each month, depending on our situation. And that's what we have for amortization. There's already some money and you're paying it back, but whatever is left in the account gains interest. It's the exact same process if we talk about retirement fund. So if we think about a retirement fund, you've saved up a lot of money in your life, so you have a big chunk of money in your account when you start retiring. Well, this chunk of money doesn't just stay static. It's in an account that has interest, which is a good thing when we're talking about retirement fund. Your amount that's left in the account is going to gain interest, and then these red parts are what you're giving yourself every month during retirement, right? So you're taking from your initial amount of money you have for retirement, you're giving yourself, let's say, an allowance of $2,000 a month. And then whatever money is left in the account at the end of the month gains interest, and then we start all over again. So I hope this helps understand the difference between an annuity and amortization. But at the end of the day, it really doesn't matter if we understand the difference between the two of them, because we are going to be using our calculators in order to solve both of these types of questions. So the most important thing to know is how to use a calculator and where to insert each numbers. For both of these situations, whether it's annuity or amortization, it really doesn't matter the word we give it, but we're going to be using our GDC calculators in order to answer these questions. So what you're going to have to use is an app on your calculator called Finance. So you're going to click on Apps. You're going to use the first app, which is Finance. And then in this, you're going to use the first option, which is called TVM Solver. In this TVM Solver, you're going to have a page that looks something like this, where you have N, I, P, V, P, M, T, F, V, P, Y, C, Y, and then P, M, T. In the next slide, we're going to talk about what each of these mean. Now, the important thing for your calculator usage is that when you're ready to calculate something, you need to go on whatever these you want to calculate, and then you're going to have to click alpha, enter, and then your calculator is going to be doing the calculations. Now, let's try and identify what each of these components are, and I'm going to ask you to fill out the diagram on your notes. First off, N. N is going to be the total number of payments. So if you're making a payment every month and you're doing this for 2 years, well, the total number of payments would be 2 times 12, which would be 24. So this is the total number of payments you make. I is going to be the annual interest rate, so the interest rate the bank is offering. And you're not going to put this in a decimal, you're going to keep this as a percentage. So if it's a 5% interest rate, you're going to type in 5. The present value is how much money is there in the account as we start the calculations. PMT is going to be the amount of the payment. Now, if you're making regular payments like every month, PMT will be how much are you making every month? Are you giving $100 every month, $200, $1,000? This is going to be the value here. Now, this PMT is a very important concept because it can either be positive or negative depending on the direction of money. So it's going to be important for you to realize, is the money coming out of your pockets and you're giving it to someone? In that case, it would be negative money. Or is the money coming towards you? And that would be positive money. And we'll understand this with examples. FV is the future value. This is how much money is in the account by the end of our total time. PY is the payments per year. So if you're making biannually payments, you're making 2 payments per year. If you're making monthly payments, and this value would be 12. And the final is, well, second to final, is compound per year. So how many times is the money compounded per year? Are we compounding once a year, twice a year, every month? This compound per year will be CY. And then the final one is you get to choose if it's end or beginning. And this is going to be, when is the compound being done? Most of the time it's going to be given to you in the question. By default, we use end, and that's what your calculator uses by default. But sometimes in the question, they're going to say compounding at the beginning of every period, da 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 da. So you're going to want to choose the beginning part. So let's try a lot of examples to try and understand these key concepts. And let's look at example 1. Anmol decides to save for a yacht. He would like to have 100,000 Turkish liras at the end of 10 years. He saves every year in an annuity that pays 4% interest rate. Calculate how much he has to save each year. Okay, so there's lots of numbers in here. We're going to try and decipher each of these. We are saving in order to buy a yacht. So if we're saving in order to buy a yacht, we need to think about what is the present value versus the future value. He would like to have 1 million Turkish liras in his account at the end of 10 years. So this 1 million is going to be our future value. Therefore, our present value, we're going to start with 0 in our account. At the end of 10 years, we're going to use this 10 years for n, and we're going to see it's going to be 10 times how much we are paying, how many payments we're making a year. So we're going to have present value and our future value. He saves every year. So how many payments is done per year? Well, he's going to be making 1 payment per year. His annuity pays 4% interest, so that's my I, 4%. Now here there's no information about compounding period, so we're going to go with 1 compound per year. So unless it's mentioned, we're going to just do 1 compound per year. And what are we looking for? Well, we're looking for what is the payments, calculate how much he needs to pay each year. So we're looking for our PMT. We don't have information about end or beginning, so by default, end is going to be what we're going to put into our calculators. So let's go ahead and calculate what is the amount of his payment he needs to make every year in order to have that money in his account. Apps, Finance, TVM Solver. So N is the total number of payments. So for 10 years, he makes 1 payment per year. So that means that N is equal to 10. Our interest is 4. We start with 0. We don't know what the payments are, so we're going to come back to that. Our final value is 1,000. And we're making 1 payment per year, compounding 1 at the end. So what we have to do is we have to move our cursor to where we want it to calculate. I'm looking for PMT payments, so I'm putting my cursor onto PMT. I click alpha, enter, and it's going to solve. And I'm going to get that the payments that I need to make are 83,290.94 cents. And we're going to use 2 decimal places when we talk about money, because that's what makes most sense for money usage. So this is how much he needs to save every year in order to be able to save enough money for this yacht. Let's do our next question, example 2. Example 2, there is £240,000 in an annuity fund on the day of Mina's retirement. If the fund pays 3.2% interest rate per annum, find the value of the monthly payments made to Mina if she plans to withdraw the money from this annuity over the next 20 years. Give your answer correct to the nearest penny. Let's go ahead and identify important information. There's money in an account, and what's happening is we're taking it out and making payments for retirement. So this would be our present value. We have money in the account already. So that's going to be our present value. The fund has, so let me write the present value before I forget. The fund has 3.2% interest, so 3.2%. Then we have find the value of the monthly payments. Again, we're looking for monthly payments, so we're going to be looking for PMT. What else are we told? If she plans to withdraw money from the annuity over the next 20 years. So 20 years, we're going to have our years times how many payments there are. There's monthly payments. I forgot this. If there's monthly payments, that means that she makes 12 payments per year. Therefore, for N, the total number of payments, it's going to be 20 times 12. So in part of the question, we're going to have compounded monthly. So I did add this to the question, but it should have been there originally. My bad for the typo. If we have compounded monthly, then that means that our compounding period is also 12. Now we're looking for what is our payment. Well, every single other value needs to be filled out here. So what is going to be my future value? Well, if we think about this, she has $240,000 in her bank account when she starts retirement. By the end of the 20 years, we're expecting this account to be empty, right? We want to use up all the money that we have. So your future value here will be 0. So let's go into our calculator and insert this information. 20 times 12. At this stage, don't click enter, but just use your down button. Like that, it's going to have done the calculation for you. 20 times 12. We have 3.2. Our initial payment, our initial value is this value. You can leave the old PMT there, that's fine. We're going to go back and calculate it afterwards. 12, 12, again, we had no information about beginning or end, so we're going to keep it as end. And now we're ready to calculate. So alpha, enter, and we get that our payment that we should be making each month, 1,355.19. And that's going to be the amount of pounds that she will be receiving each month for 20 years. Now, why is this negative? Well, this value is negative because the money is coming out of the account every month. So the direction of the money is very important, right? It's coming out of the account every month. Good. Now let's look at 3 typical examples for amortization. And we're going to use the same scenario for each of these. So the scenario we're going to have is you take out a loan for a new house of 250,000 euros. The interest that the bank charges you is 3% and it's compounded semi-annually. You will be making monthly payments for the bank. Let's see what's going to stay constant. This is going to be your present value. That's the amount that the bank gives you. We're going to have I, that's going to stay constant. Compounded semi-annually means that our compounds per year will be 2. And you're making monthly payments, so your payments per year will be 12. And this is going to stay constant for all of our questions. So let me go ahead and write it down for our first question. Okay, type 1. If you pay off your loan, and I'm going to use a different color. If you pay off your loan in 30 years, how much will you be paying per month? So we're looking for PMT here, which is a very often what we're looking for. If we're looking for PMT, we're going to use the 30 years. So 30 is going to go in our value for N, but N is the total number of payments. So every year you're making 12 payments, so our N is going to be 30 times 12. At the end of the 30 years, we should have been able to pay off our entire loan. Therefore, there should be absolutely no money left in this account. So we're going to go ahead and calculate this. So our N is 30 times 12, down arrow, 3. We initially have 250,000 in this account. I'm going to skip this, 0, 12, and 2 compounding periods. I'm going to go back to PMT, alpha, solve, and we get 1,051.51 rounded to the nearest penny. So if you want to pay back your loan in 30 years, this is how much money you should be paying each month. Okay, let's do our next example, or next type, remembering that we still have some values that are constant from our initial question, right? Our initial start. Okay, now, if you pay off the loan in 30 years, okay, check what we've done before. How much did you pay for interest? So now, this is a question that we're looking for interest. And in order to calculate interest, we need to look at how much money did we actually pay and compare that to how much money the bank gave us. So for interest, it's going to be the total amount paid minus the initial loan. Right? And this is super important for us to keep in mind. Interest is going to be the total amount minus the initial loan. So I'm not even going to be using the TVM solver for this. So my interest is going to be, I am giving the bank 1,051.51 each year for each month for 30 years. So 12 times 30, right? This is the amount of money I'm going to be giving the bank. Initially, the bank gave me 250,000. Let's go see what is the interest that I actually paid extra to the bank for this loan. So times 12 times 30 equals to this, minus our 250,000. So after 30 years of paying off this loan, I actually gave the bank 128,543.60 cents. This is how much extra I was paying because I took the loan and took 30 years to pay it back. This is the reality of the situation we live in, is that the interest is actually very, very high the longer we take to pay back a loan. Okay, let's do one more type of question. If you decide that you can only pay 1,100 per month, how long will it take you to pay off the loan? So sometimes we're restricted with the amount of money we actually can give the bank, right? So if you can only give 1,100 per month, let's see how much time it's going to take you to repay the loan. So now we're looking for N. We still have the same interest rate. We still have the same loan from the bank, compounded 2 times a year, and we're going to do monthly payments. Our future value is still 0 because we want to empty up that bank account. Now, we are giving this amount of money each month. So that money is getting out of our pockets. So this should be a negative value here because the money is coming out of our pockets. I'm going to go ahead into my apps, into TVM Solver, and I'm looking for N, so I can leave this blank. This stays there. My payments is now negative 1,100. Future value stays, all these stay exactly the same. And I'm going to go alpha solve, and I'm going to get that the value of N is 335.1. Now this, we're looking for how long will it take. That means it's going to take me 335.1 months, right? Now with what we've learned so far, I would like you to try this example for homework and have it ready for next class. And we're going to see which bank is better. Should Sandra go with bank A or should she go with bank B? And this is your homework for next class.